Hello everyone, welcome to Spark Study. In the last video, we studied something about the BODE plot. We have studied how to find the value of k or gain with certain frequency, with respect to certain frequency. And in this video, we will study some more concept. The terms we have studied in the last lecture that need to be understood using the plot. So let us start the same problem, and here the problem will be extended to find the phase crossover frequency and the gain crossover frequency, which we have studied in the last class. So the phase crossover frequency is omega pc. P stands for phase, C stands for crossover. And I repeat the definition of that: it is the frequency in radian per second at which phase of OLTF is 180 degree or angle of OLTF is 180 degree. Okay, so let me get the same diagram, same plot. uh, I repeat, the frequency at which phase is 180 degree. So this is my phase plot. It is asking the frequency at which phase is 180 degree. This is 180 line, and this is my phase plot. So we need to bother about this plot only. Okay. So at this plot, we need to find that point which is equal to 180 degree. With respect to 180 degree, what will be the frequency? So I'll take a straight line from 180 degree which need to intersect the phase axis, and after that we take the vertical line from the intersection of the phase axis and the 180 degree line, extend to the frequency. We'll get this line, the frequency will be 0.5 radian per second. So this is nothing but the omega pc. It stands for phase crossover frequency. I repeat, the phase crossover frequency is the frequency at which OLTF is 180 degree, or the frequency at which phase of OLTF is 180 degree. So I have drawn the BODE plot, and exactly at 180 degree to the phase plot, I have drawn a straight line, a horizontal line, this one, and from the intersection point of one horizontal line and the phase plot, I have taken a vertical line which will be intersect the x-axis or frequency axis. The intersection point is nothing but the zero point 0.5. This is the omega pc or phase crossover frequency. Okay. Similarly, what is the gain crossover frequency of that same problem? And it was represented by omega gc. G for G stands for gain, C stands for crossover. And we have known the formula that the frequency at which magnitude of the gain of OLTF is 1 or 0 dB. Here the concept is gain, so we deal about only the gain line or gain plot at which 0 dB or 1, but we have plotted for dB, not for the same linear scale, so we'll bother about the dB scale and the gain plot. So here the blue line will be my gain plot or approximate gain plot, and 0 dB is the scale. So from 0 dB, take a horizontal straight line which need to be intersect to the gain plot first. Then after, from the intersection point, okay, from the intersection point of horizontal line and the gain plot, we take a vertical line which need to be intersect to the frequency, because our ultimate aim is to find the frequency. So this is the frequency, that is 1 radian per second, and 1 radian per second is nothing but the uh, gain crossover frequency. Okay, so we have studied this phase crossover frequency and also gain crossover frequency. I told you, using that two concept or using that two frequency, we need to find out the margin. Okay, BODE plot ultimate aim is to find the margin. So what we need to find? The gain margin and the phase margin. That means how much extra phase I can add or how much extra gain I can add, so that my system is in between stability. So beyond that it become unstable. Okay, so same problem, let me extend into also find the gain and phase margin. Okay guys, this problem is not actually the problem to find the phase and gain margin, but I have taken this example So everything, every question have this thing to find, but do not bother about the solution. Just learn the concept first. Okay. So what this is my from this diagram we have found the omega pc. Okay, and here omega gc. So these two have found out omega pc equal to 0.5 and omega gc equal to 1 radian per second, which is shown here. Now what I need to find again, let me make you clear what is a phase margin. Okay, phase margin is the additional phase I need to find out. See here, the formula to find is 180 degree plus phi gc. Here this is phi gc, guys, this is not omega gc. That means we need to find out the angle corresponding to the omega gc. So what we did, so this is my omega gc plot. Omega gc equal to 1 radian per second, and we need to extend this this line to intersect the phase line, because our aim is to find the phase or phi gc. So it may be top side or bottom side, we need to adjust the straight line. So we can see this is the intersection point, and this intersection, from this intersection point we have extended the line to the angle axis or phase axis, and we found that this value will be 170 degree, or phi gc will be 170 degree. Okay, guys, this should be comes in negative. An actual problem, it should come in negative, so that we can have a good range. Anyway, we have extended this problem, so we just learn the process how to solve it. So here 5gc becomes 170, and I told this formula gamma equal to 180 plus 5gc, and which will be extend like 180 plus 170, and that is the value of 3 uh, 50 degree. Okay, but 350 degree, is it possible? Okay, like we have पहले we have वन मतलब पहले 180 डिग्री था, फिर 360, मतलब एक सर्कल को दो बार चक्कर लगा देना है, समान है. So like that is not possible for this problem. I just shown you the step. You just follow the step to find out. Generally, this value, I mean this 5gc comes in negative, so that 180 plus or minus something will be less than 180 degree. So that is the value of gain margin. So what is the phase margin? You know this, sorry, what is the we have found the phase margin. Now what is the gain margin? I told you we need to find out the omega gc. Okay, so omega pc, and we need to find out the gain. Replace the omega by omega pc. So this is the transfer function, we have got that, and we know how to find out the magnitude. So the complex magnitude will be, let's say, a plus ib. The magnitude will be a square plus b square under root. Similarly here it will be, you need to find out the magnitude. Here 1 square plus point square, point 2 square under root. Here 1, likewise 1 square plus 0.2 omega whole square under root. Here 1 square plus 0.02 omega square under root. Here likewise we first form the magnitude equation, then replace the omega by omega pc, what we have found from the BODE plot itself, and we'll get the value, and multiply 20 log, then we'll get this thing in 20 log. So multiply minus 20 log. Okay, so we'll get, so after multiplying 20 log, we just take it minus, so that it will get a gain margin. Okay, so this is homework for you, just to find it out. Thank you very much. If you understood the concept, don't forget to like, subscribe, and share to my channel. And if you have any problem or any doubt, please note down in the comment section.